Hey everyone, welcome back to the Navigant Credit Union Broadcast Center. I'm Molly O'Brien. This is Kim Arcand. She is the visualization lead for NASA's Chandra X-ray Observatory. So thank you so much for joining us.
Thanks for having me.
Yeah, welcome back. And today we are talking all things space. So we kind of did the technology thing and now we're moving on to science, which I'm super excited. We're doing women in science for the next the next part of this show today. So it's pretty exciting. So thanks again for coming.
Sure.
And we're kind of just going to have this discussion on all things space. We're talking about a couple different topics. So I'm excited to have you here. And we're leading off with black holes, which is scary, but you say not so scary, right?
Not so scary. Not
so scary. You said in a recent blog post that just a few decades ago, black holes were the stuff of science fiction, and today you can actually watch them in action. So what do you mean by that?
Sure. Well, so a black hole, just to start with a simple definition, essentially an area or region of space where the gravitational pull is so strong that nothing can escape, not even light. Which does make black holes invisible. But you can actually see how they work by their gravitational effects on the objects around them, the stars, the gas, the dust. So in the past 20 or so years, there have just been an amazing amount of discoveries about them. And we know now that most galaxies, for example, have a black hole at their center. And when I was young, I think I kind of thought of black holes as like these giant Pac-Mans.
Oh, totally. Right?
Going through
100%,
space, eating its dots, hopefully not planets. But really, it turns out that these objects they can be about destruction, yes, but they can also be just as much about the creation of material. And so if we look at the black hole at the center of our Milky Way, for example, it's called Sagittarius A star, and it's about the size of maybe 4 million suns, but compacted into a space the size of about one sun. So that's a really powerful, strong thing that you're thinking of. But it's actually kind of quiet and just chill. It's just sort of sitting there at the center of our Milky Way, doing its own thing, minding its own business, right? So some black holes are not scary at all. Now, there are others, such as the one that was nicknamed the Death Star galaxy. This is a galaxy far, far away that has a very supermassive black hole at its center that is essentially shooting out this high-powered, high-energy beam of particles that is so strong and so massive, it's going out of the galaxy and it's striking another galaxy, a small little galaxy that's in its path. And because it's high energy radiation, essentially, well, the stuff in its path, probably not in the best, it's just not the best place to be. So they nicknamed it the Death Star Galaxy because, well, Star Wars. I love Star Wars.
It's fascinating. I'm glad the people who are seeing and finding these things have a good sense of humor, at least, right? Because if I saw something like this, everybody run, hide, get near. It wouldn't matter, right?
Right. Yeah, there's nowhere to go.
No.
But they're mostly not like that. And I think, all right, if we did a quick exercise, so black holes can just kind of, hang out. They all have to obey the laws of physics, so they are in orbit and they're doing their thing. But there is the Schwarzschild radius, which is essentially the point past which nothing can escape. So if we took our own solar system, for example, and we magically plucked out our sun and replaced it with a black hole that's about the same mass as our sun, which would be a really tiny baby black hole, but just pretend.
That would be a tiny one.
By the way, our sun could never become a black hole. I feel like I need to say that really quick. Our sun is too small and boring of a star, and that's not an insult. That's a good thing. Our sun is perfect, just the way it is. So, all right, we magically take sun out, replace with this super tiny baby black hole. The Schwarzschild radius, that point of no return, is only about 3 kilometers. So we at 92 million miles
that doesn't seem very big in
space
term.
Since Earth is about 92 million miles from the sun, we would be in absolutely no danger. But of course, we would then be missing our sun, which means no heat, no light, and no photosynthesis, stuff like that. But that would never happen. So
that's fascinating.
Yeah,
absolutely fascinating. So, I mean, how does our perception this is relatively over a not very long span of time, our perception of black holes has changed in the scientific community, right?
Yeah, I mean, in the scientific community it's changed a lot, and I think also, science fiction has some impact on how people understand things. I think that's where I probably got this picture of a giant Pac-Man going through the universe, gobbling up everything in its path, you know? So I
Sucking
think one
everything in.
affects the other. Science improves and learns more, and then writers probably incorporate more of that into their writing, and it gets more broad into sort of the general media, if you will.
Yeah, no kidding. And that's why we have you to help us out, right?
Sure.
To help us to change our image.
Yeah.
Talk to me a little bit about how scientists learn and visualize and conceptualize what happens with black holes using Chandra.
Sure. So the Chandra Observatory is really great to study black holes because it's that high energy aspect of them. So, for example, at the center of our galaxy is our very own supermassive black hole, Sagittarius A star.
Which is nice, she said.
Which is a cool one.
It's
Just
just
chilling, minding its own business.
Relaxing.
But we can see things that go near the black hole. So a few years ago, there was this really interesting result from some scientists that had been looking and seeing these X-ray flares that were coming out of the supermassive black hole. And when they studied it, they realized that it was likely due to asteroids that were actually falling in to the gravitational pull.
And they could see it?
And they can't see it
They can
directly,
see-
but they can calculate
they
it
can see-
based on what they're seeing from the flaring material coming out.
Wow.
So they think there is just this massive cloud of, you know, millions, if not billions, of asteroids just hanging out at the galactic center that when they lose enough energy, they fall in and, well, bye-bye.
That's amazing.
So yeah, so that's, you kind of have to look indirectly because of course light can't escape the black hole, so you can never see a black hole directly, but we're getting better and better all the time at being able to image closer and closer to that cutoff point.
Wow.
So yeah,
Wow.
black holes.
Jeez. I'm trying to think of, and being able to see but not see what's
Right,
around that.
right.
And just the fact that we have the technology that gets that
Even
far.
to that point,
Right?
right? Exactly, I know.
That's so incredible.
That you have to be able to understand these objects by what impact they're having on the objects around them. That's so cool.
That's pretty exciting.
It's pretty cool.
So just covering, I'm just looking over our notes here, just
Yeah.
talking about how fun all that stuff is. And so you mentioned asteroids. So I think, what else? Should we cover anything else about black holes?
No, I think that's it.
That's good.
That's all I can think of.
Okay, well,
Yeah.
I'm sure there's a lot more you can
Yes,
think of, but
that's a good black hole 101.
That's a good
I
black
think.
hole 101.
Yeah.
So you mentioned asteroids. Tomorrow, June 30th is World Asteroid Day, and I saw that and I was like, wow, that's kind of cool. What should we really know about asteroids besides they kind of fall into black holes every now and then? And why is there World Asteroid Day? I didn't even know that was a thing until earlier this week.
Yeah, actually, I didn't know it was a thing until maybe a few weeks ago. So, yeah, everybody has something to learn every day. Right, so asteroids are just small, rocky bodies that orbit our solar system. And for the most part, we know where a lot of them are, but there's a lot that we don't know as well, because the size range of these is pretty immense. It goes from really small, like dust particle size, to something, say, 1,000 kilometers across. And everything in between. And there are some in the main belt in between Mars and Jupiter, but then there's also that are kind of gone rogue and have different kinds of orbits. So there's still a lot to learn about them. And I think what's great about having a World Asteroid Day is that it's just kind of a reminder that there are things on this planet that we can control, there are things that we can't control, but we also live in a broader ecosystem. We have a solar system that we're a part of, and we're part of a galaxy, and that galaxy is part of a group of galaxies, and that group is part of the local universe, right? So I think it's just a great reminder to, for one, look up, and for number two, just realize that not everything is just about Earth, that we actually do have other stuff going around us. And I think astrophysicist Neil deGrasse Tyson put it really well, and I'm just going to paraphrase his quote and say, we'll probably get it wrong, but...
And we can then all look it up.
Okay, good. Asteroids are essentially nature's way of asking, how's that space program going? Because it really is kind of like a prod to be like, oh yeah, there are these objects in the sky that we need to learn more about, so let's go do that. So that's how I like looking at it. It's a way to reflect that there's more than just us here.
I like that.
Yeah.
I saw on, do you ever watch those, like, antique shows or anything like that? It was on, my husband's a historian, so he loves that stuff.
Okay.
So I saw, where I'm getting with this, I saw this mailbox that sold for, like, 18 grand
Oh.
or 30 grand, something like this. And I'm like, what the heck? And it was
Yeah.
smashed. So So I thought some kid hit it with a baseball bat.
Oh, it was hit by a meteor. Oh
Yep.
my gosh.
Hit
That's
that.
cool.
So I thought,
how badly was it smashed? Just curious.
it was smashed. You
Like,
could
unrecognizable sort of.
It
mailbox?
looked like a mailbox still, but it was pretty smashed.
Interesting.
It was pretty
Yeah.
smashed. But yeah.
So right. So that's an interesting sale though.
Right.
But yeah, it is. It's a great point. Like for the most part, we're safe. I mean, these events happen across long periods of time, but it's just a good reminder that it's not all about us. That's all.
There are these things
Yep.
floating around in space. That's the thing, though. How often, and you made the point about how science fiction and whether it's books or movies,
Yes.
that kind of incorporates people's minds. Whether
Sure.
you read the textbooks, you read the science books,
Yeah.
but then you also have
the movie,
Hollywood,
see
and
Armageddon
that-
or Deep
exactly.
Impact.
Exactly.
Yeah.
You have that kind
Yeah.
of stuff, and
Yeah.
then people either get nervous or say that's never going to happen.
Yeah.
So is it something like World Asteroid Day, maybe even just a day where we get reminded, freshen up what's really going on in the world?
I think so because it's just a reminder that we are part of a bigger thing, and we cannot control that, but we can control how we react to that knowledge. So if we know there are these bodies in orbit, and some of them could be detrimental at some point in the future, but we don't know when, it doesn't hurt to put some assets towards solving that problem, which there are already lots of scientists doing, and I'm sure many kids out there, perhaps some watching today, that will grow up and solve the issue completely. Who knows?
I like that.
Yeah.
That's fun. So another thing that's super exciting in the world to many kids and many scientists and many adults, there is a total solar eclipse happening quite soon. So the date, Monday, August 21st of this year. Just so we can all kind of freshen up on our eclipse terminology. Just explain to us what that is and why it's an exciting day.
Sure. So it's really exciting, I think, for me, because the last time we had a total solar eclipse on the continuous part of North America was about 100 years ago.
We were not alive.
I was for sure not alive. I'm not that old. And this is just going to be an amazing opportunity to see one. So what a solar eclipse is, essentially the sun, the moon, and the earth all line up at a really good distance for the sun, essentially the sun's light to be blocked completely by the moon. And the moon will cast its shadow on earth. And I think what's really cool about that, there are some kind of unexpected things that happen. One is the temperature actually drops dramatically. Some people have said up to 20 degrees, I guess, depending on humidity factors and the strength of the sun that day.
Jeez.
And all that. And since it's August, we'll actually probably be able to feel it pretty strongly, that temperature change. It gets very, very dark. And it gets so dark that the animals and the insects around you get very confused. So nocturnal animals think it's time to go. The crickets start to chirp, and the daytime animals, like, what do I do? Do I go to sleep? It's a very interesting thing. And also the winds even pick up a little. So there are all of these sort of physical aspects to an eclipse that I think are really cool to think about. And for about 2 minutes, that light of the sun is just gone. So I think it's also kind of another great way to think, I guess, again, beyond yourself, right? We depend on our star for the life that we have here. We need that energy, that heat, that information, the photosynthesis, all of that. So for us, I think it's another good opportunity to kind of reflect. And here in Rhode Island, unfortunately, you won't have totality of a complete blocking of the light from the sun. I think it'll be about 65% coverage, which is still pretty cool.
Yeah.
It won't be dark, but you'll definitely notice the change. But of course, anyone viewing must use the proper eclipse glasses, because even just a second of looking at the sun and you can do irrevocable damage, permanent damage to your eyes. And you can find those eclipse glasses like everywhere these days. They're at
Yeah.
the store. I've seen them at Target.
Oh, really?
Yeah.
Okay, yeah. So this is good to know, because I was reading about this. So I read that the Moore Foundation will be providing public libraries across the country with 1.2 million solar viewing glasses for free. So check out libraries, apparently Target.
Yep.
So go see if you can pick some up. So the date's August 21st, obviously before then. Do you know, like, kind of about what time in Rhode Island?
Sure, yeah. So it's starting in Oregon, and then eventually will make its way here. I'm going to be in Charleston, South Carolina to view Totality, and I think, yes, I'm very excited because I've never been there. And I think that time Totality might be around 2:45. So pretty much from 1 to 3 is kind of like the sweet spot that you want to be paying attention that these things are occurring. But around a little time after 2, you want to be paying more attention. And by 2:30 for sure, you want to be locked down so we're good to see it.
Okay, so Kate, we're gonna have to figure out how to broadcast live from
to figure
it out.
That would be cool.
Yeah.
Of course, fingers crossed there's no clouds. Yeah, that would be a bummer.
Come on, Earth, atmosphere.
Yeah.
Right. So we're gonna try to figure out the best way to figure that out. Get some glasses, that kind of thing.
Mm-hmm.
So there are certain places. So we're gonna be at 65-cent viewing. So there's certain places across the country that are gonna have total viewing.
And that'll be beautiful. Yeah. So from Oregon to South Carolina, there's about 14 states that get the Totality, which is really cool. Because again, we haven't had that much coverage since it was 99 years ago, I think, to be precise. So yeah, this is the opportunity of a lifetime. This is supposed to be the most watched solar eclipse in history, from what I understand too. So that's another really cool thing to be a part of, something even bigger than yourself.
It kind of gives you goosebumps thinking about it. So over the years, we've had, because you hear about this every now and then, but it's just partial eclipses, and then you have lunar eclipses,
right.
And is it just kind of fun to hear and be a part of something like this?
I think so, but I mean, I'm like a super dork, so I don't know if I'm the right gauge to try, but I do think it is, again, it's that whole reminder that we have one sun, we've got one Earth, we've got one sun, we've got one solar system. It behooves us to learn more about all of these things.
So that's true. And I think, too, you spoke about this just a moment ago, but kids, just being able to be a part of something like this, and it gets kids really excited about science, which we'll talk about in...
this is a bucket list item for sure.
No kidding, my goodness.
Yeah, get excited.
So a couple more things before you go. So you will have a book coming out in November, but it's available for pre-order now. The cover is beautiful. We kind of got a peek of that not too long ago. Magnitude is the title, and shows the scale of our world in a clear visual way that is relatively, this is what was in the cover of the book, I believe. Cover topics, let's see. You and your co-author take a look at the limits of size, mass, distance, time, temperature, and the universe. So it's fully illustrated and really just takes readers on the journey to understand how the world works. So you've worked on other books before. What led you to this topic to really help readers understand the universe and put it into a book?
Yeah, so kind of what we've been talking about. So in this conversation alone, we've talked about billions of suns, we've talked about millions of miles, we've talked about all different kinds of scales. And I think even when you read the news, you hear about, billions of dollars here and millions, these numbers are so large.
Yeah.
And I think this book is a way for me and my co-author, Megan Watsky, to try to figure out how best to... Megan's on vacation.
She's not watching, hopefully.
She's not watching. So it's a way for us, I think, to just try to understand the magnitude, pun intended, of how big these numbers can get, and also how small. So, for example, if you just think about the topic of wind, our own personal relationship with wind might be in a field, you see dandelion seeds being blown across the field in a graceful breeze, right? That's kind of maybe one memory we might have.
Yeah.
But then you can also think on a larger scale, winds occur in cyclones and hurricanes at hundreds of miles per hour, right? And then if you go even bigger to galactic winds, those are shooting even more fast than a hurricane or a cyclone can, and at a huge scale across an entire galaxy, essentially dispersing material throughout it. So it's interesting to be able to think about a galactic wind, but without your personal relevance, I think, of how you interact with winds, it might feel more abstract. So it's being able to find those stepping stones, how to talk about something on a really grand scale or a really small scale, by finding those in-between spots that you can relate to. And that's kind of what the book is about. And it's like a highly illustrated, fun, accessible, I hope, approachable way to think about the universe, big and small.
And I really like that idea, and it's exciting to think about that because making science understandable and visual, which is what you're doing with this book, I think is really important. Was it fun for you to be able to work on that? Because you think of, there are so many books out there, you think textbooks and then you think of educational books, and this is what I would think was sort of in between. You're not doing the kid book, you're doing the adult reader book, right? You're not doing a 7th grade science book. So was it fun for you to be able to put something together like this?
Yeah, I love writing. I mean, I just really enjoy being able to sit down and think about interesting ways to talk through this type of material, to make it interesting, to make it a little bit more accessible. And we worked with an illustrator, Katie Peak. She's very talented.
Hi,
Katie. And I loved seeing how she could take our ideas and create them into these beautiful visualizations. And it just made everything feel just very cohesive in a really fun way. And I don't know, I really hope people enjoy it. It's kind of like a Powers of 10 idea. If you've ever seen the Powers of 10 video from Ray and Charles Eames, a very classic thing, but taken much broader, so beyond size and distance to temperature and pressure and acceleration and just a host of things to be able to explore in our own backyards and well beyond.
And very well beyond.
Very well beyond.
That's
yes.
awesome.
Yes.
So before you go, I want to talk to you a little bit about your involvement with the Rhode Island Museum of Science and Art, who actually is our next guest.
Yes.
So hi Bonnie, she's going to come out here in just a minute. So before you go, I want to talk to you. So they finally found their permanent home after 7 years of being so involved with the community and doing pop-up exhibits. Finally found a permanent home, which is very exciting. But you've been involved, you're on their board. Talk to me just a little bit about your involvement with them, and it has to feel pretty good to finally have a home.
It's very exciting. It's been, a goal that we've been working towards for a while. I've been on the board for a few years, but I've always been a fan of Bonnie's, who you'll meet in a minute. She just thinks of the world in these really cool, interesting ways. And it's all about unleashing curiosity and creativity. So I think a lot of people have this misperception of, say, science, that it's these facts that you have to memorize and that's how you learn, but it's really more about exploration. And science and art have this long history together of, needing creative minds to sort of have that innovative thought. And those really interesting processes to go through to get where you want to be. So RIMOSA, the Rhode Island Museum of Science and Art, is now like a physical space to reflect that. It's a fun maker space. It's not something that's like scary. It's just it's got a great sort of feeling to it. And I'm very excited to have local Rhode Islanders be able to explore it and spend some time in there and just learn something new.
Awesome.
Yeah.
Super exciting. And there is a place to explore space as well, right?
Yes, so there's actually a NASA exhibit there right now on light. So you can explore things like light, magnetism, so many fun things to do. It's great.
Super exciting. Well, congratulations.